GNSS is a satellite-based positioning system. It is composed of user, control, and satellite segments and allows precise location positioning quickly and with high accuracy. GNSS is based on range measurements. These range measurements are derived from measurements of a broadcast signal that may be either uncoded or coded. Uncoded carrier phase signals are the basis for most precise position determinations, but are of limited use for locating features due to measurement requirements. Code phase measurements are primarily used for feature collection and entry into a GIS. Range measurements from multiple satellites may be combined to estimate a position. GNSS positional estimates contain errors due to uncertainties in satellite position, atmospheric and ionospheric interference, and poor satellite geometry. These uncertainties will vary in time and space. GNSS are satellite-based technologies that give precise positional information day or night in most weather and over most terrain conditions. GNSS technologies may help navigate and track moving objects large enough to have a receiver, to carry a receiver. Receivers shrink in size, weight, and power requirements each year. A GNSS stands for Global Navigation Satellite System, and it's a constellation of satellites plus ground control segments that allows precise location on or above the Earth. Some of the current implementations include GPS, GLONASS, and other satellite navigation systems that are under development. A global positioning system, GPS, is based on observations of signals transmitted from satellites. A different system, GLONASS, which stands for Global Navigation Satellite System, is Russian developed and maintained, and it's a system for coordinate measurement and positioning. Galileo is a European-based GNSS system that's not done yet. There are several existing satellite systems for GPS today. Navstar GPS in the United States has been operational since the early 1980s. GLONASS, which again is a Russian initiative, was started in 1993 and it went fully operational in 2012. Galileo is a European system that will be fully implemented by the year 2019. BeiDou is China's GNSS system and it's under development. And India's regional system is IRNSS and it's likewise under development. There are three main components or segments in any GNSS. The first is the satellite segment. This is a constellation of satellites orbiting the Earth and transmitting positional signals. The second component of any GSS is a control segment. This consists of the tracking, communications, data gathering, integration, analysis, and control facilities. The third part of any GNSS is the user segment, the GNSS receivers. A receiver is an electronic device that records data transmitted by each satellite and then processes these data to obtain a three-dimensional coordinate. There is a wide variety of receivers and methods for determining position. Receivers are most often small handheld devices. The satellite and control segments differ for each GNSS. The Navstar GPS includes a constellation of satellites orbiting the Earth at an altitude of approximately 20,000 kilometers. Initial system design included 21 active GPS satellites and 3 spares. Every satellite orbits the Earth twice daily, and each satellite is usually above the flat horizon for 8 or more hours each day. Experimental and operational satellites have outlasted their design life, so there have typically been more than 24 satellites in orbit simultaneously. Between 4 and 8 active satellites are typically visible from any unobstructed locations on Earth. The GLONASS system is another currently operating GNSS. GLONASS was initiated by the former Soviet Union in the early 1970s. Satellites were first launched in the early 1980s, and the system became functional in the mid-1990s and fully operational in the year 2012. The GLONASS system was designed for military navigation, for targeting and tracking, and is operated by the Russian Ministry of Defense. There's control and tracking stations similar to those for the Navstar GPS system. A receiver decodes each signal to identify the satellite, transmission time, and satellite position at the time the signal was sent. The receiver combines this information from multiple satellites for positioning, in other words, triangulation.